Okay, thank you, Milana, and hello, everyone. So indeed, my name is Roberto Cuccu. I work also myself in the computing and software support team in the user services. And I will be giving you this introduction to the Atos HPC facility and ECGate services, which are the main computing platform that we offer to our user. So we'll be picking up from where we left from the previous presentation. And this one will be a session that is split in first part in presentation that will last around half an hour, and then it will be followed by some practical session. So let's get started and with an introduction overview of the HPC facility. So the HPC facility is composed by four complexes, so four clusters that are named AA, AB, AC, and AD. So these clusters are split in the two computer hall of the data center that you have seen also this morning in the virtual tour for redundancy and resilience purposes. And each of these complexes is composed by two main partitions. So these are the parallel partition and general purpose and interactive login. The parallel partition comprises the majority of the nodes, so we are counting 1920 nodes for parallel jobs. And each one of these nodes is equipped with 128 physical core, so you might think the double if you're using multi-threading. And when you submit a job on the queue that is mapped to this partition, the parallel one, so each job is assigned to at least one full node. And of course, you can request multiple nodes at the same time for the same job. So in the case of the general purpose interactive login, so there are less number of nodes, 112, and these indeed are for general purpose use. They have more memory and also a local SSD disk attached. However, in this case, each of these nodes shares the multiple jobs of multiple users on the same node. So indeed, the queues that are mapped to this partition are meant to serve serial jobs or small parallel ones, while for the parallel ones, there is the parallel partition. Each of the complexes has its own instance of the resource manager and job scheduler, which is Slurm, which will be covered in a session tomorrow that will also show how to submit job to the system. And in addition, there are the same file system, so same storage location dedicated to the users in each of the complexes. And also the same application and software stack is installed in sync in every of the complexes. Just a note that it's not here in these slides, but was also mentioned this morning. We're also preparing a small GPU cluster that will be soon open to authorized users. Beside the HPC facility, there is the ECGate service, which is basically a subset of the main HPC that is meant to serve users that don't have full access to the HPC facility. So these users might include the user from the cooperating states or also other users that don't require full access. So you might think about the ECGate service as a virtual complex, which, let's say, is composed by nodes that are taken out from the GPL partition of each of the four mentioned clusters, so AA, AB, AC, and AD. ECS also, it has its own Slurm scheduler that is able to spawn jobs over these nodes. So there are no parallel partition here. Also in this case, however, there are the same file system and software stack everywhere like the HPC. And ECS, anyway, there are less resources available for the jobs that are submitted. Indeed, it is meant to be used just for serial or very small parallel jobs. However, the difference with respect to HPC, the jobs that you submit here will be not accounted, so there is no charging in terms of system billing unit for the jobs that run here. So it was already mentioned, but let's mention it again. All the topics that I'll be covering in this presentation will be also present in more detail in the user documentation that we invite also every new user on the platform to have a look around and skim through the different pages to get familiar with the basic offer on the service, and also to have it as a reference point in case needed to dig into much more information or if you have any doubt. You will be seeing also some link on the slides that you might find as reference for that particular topic. So when you access to the system, and also we have been seeing in the previous presentation, you typically SSH through one of these generic host name, either HPC login or ECS login. So these might be considered like the main doors to access the service. In the case of HPC login, you might also note that if you attempt a different connection from different terminals, you might end up on a different host. That's because there is a load balancing that spread the user connection around multiple login nodes to spread also the load. That doesn't happen instead for ECS login, where let's say the generic host name is mapped to one single host. These host names are mapped usually one of the login node of one of the complexes, and we tend to not change it so often. However, it's possible that for some maintenance they will be mapped to another complex. Beside this host name, there are also another set that are HPC batch and ECS batch. So these host names are meant to be used for submitting remote jobs to the system. So in this case, we want to separate, let's say, the interactive SSH connection that will happen on the HPC login to the remote job submission. So in that case, there is an overload of some login nodes that shouldn't affect the remote job submission. So these nodes are, for instance, the one that should be configured for ECFlow users, so the workflow manager that we adopted at ECMWF and will be covered also during this training course. Just for information also, each of the complexes has its own proper doors, either the login or the batch ones. However, if you don't have any specific reason to access one complex in particular, just stick to the generic host name, because also some complex might go in maintenance, and if you use the generic ones, at least you are sure that you are using the available one. Also, there are some nodes that are meant to be used to host the Linux, install the Linux cron tab if you wish to do so. And finally, also, there is another node that are this HPC log that is meant to serve a very particular use case to host the log server for ECFlow user that want to serve their output logs to the ECFlow user interface. So a very particular use case for that. In terms of shell, as it was mentioned, by default, we provide new users with bash as a default. However, also for legacy purposes, we still support as a login shell also Korn shell. You cannot, if you for any reason you want to move from bash to Korn shell, you cannot do that autonomously. You need to raise a request and we'll change it for you. You have the possibility to customize your shell environment by setting up the usual standard Linux files like .profile, .bash profile, or .bashrc or the kshrc. For setting up aliases, exporting variables or functions, and or also the preloading HPC modules. In the case of bash, also it's possible to customize the session logout with the .bash logout file. So now let's have a look at to the storage location that every user on the platform has available. So it was already mentioned that as soon as you access the system, you get access to your user home. And as a member state user, you have 10 GB of quota available. So the main feature of this file system is that you have there is a backup in the ECMWF archive of this location, and also there are frequent online snapshots that allows every user to recover any file from the past if needed. So this file system is based on network file system technology, so NFS, so not particularly performant. However, it's still good location to store some configuration files, some source code that doesn't take much space, or some documents that are important for you because there are also these backup and frequent snapshots are available. Beside home, there is the per file system that is again based on NFS. In this case, there are no backup. However, also in this case, there are online snapshots are available that allows you to recover some files. You have a bigger quota here, so 500 gigs as a member state user. And also for this reason, the snapshots are taken less frequently than home. In this case, so since it's based on an FS, it's also that not particularly performant. And in addition, especially if you're running jobs on the parallel partition, so parallel jobs, there is a throttling on the bandwidth between towards perm. So you need to be careful to not use it for jobs that requires a fast I/O operation, and neither to store here your standard output and standard error of your jobs. So these two, as it was mentioned in the previous presentation, are also available as a mount point on your VDIs. So beside those, we start having a look at the HPC file systems on Lustre. And the first one is Scratch. You might consider Scratch as your working directory for your job that runs on the system. So this file system is performance, since it's based on Lustre parallel file system. You have bigger quota here, so 2 terabytes as an ECS user, and 50 terabytes as a member state user. However, on the contrary, with respect to the previous shown file system, here you don't have backup, neither snapshots. And also, you need to be careful because there is an automatic purge that clean up files that has been not used or accessed for more than 30 days. So just consider this for storing intermediate data or some data that is required at runtime, but not to store anything that is supposed to be stored there for longer term. If you want to combine performances and also the possibility to store the file permanently, you might consider using HPC per. So also this file system is based on Lustre, and you have less quota than Scratch here, so 100 gig and 1 terabyte. Also in this case, you don't have a backup and neither snapshot. However, the files here are kept permanently, so there is not that automatic purge that deletes files here. So beside those online file system, if you plan to store data for a longer term, you might consider also storing them on the ECMWF file system, ECFS, that will be covered also in a session during this training course. So this ECFS is not a very proper file system like the other ones, but you might think about that like storage location that we reserve to the user of the facilities on our data handling system, so that relies on tape archive. So since it relies on tape, you might understand that the retrieval from this place is quite slow. So it's just to be used for storing a big amount of data that you don't need to access frequently and for longer term. So in this case, you might save some quota from the other online file system. So beside those, we might also we have a possibility to have some temporary storage location that are reserved to the user sessions and jobs. So the first one that we cover is the TMP-DIR. So in the case of jobs that runs on the GPL partition, so the interactive session or the small or serial jobs, you have this location that has by default 3 GB that expandable by request on up to 100 gigs on the local disk on the compute nodes that are on SSD. So instead, on the parallel partition, this TMP-DIR is mapped to be in memory. So you have all the memory available there. And at the end of your sessions or your job, the content of this TMP-DIR will be automatically cleaned up. Beside that, you have the possibility, there is another storage location that is created for every session or job, which is scratch DIR. So this is basically a location that is created under your scratch, so also taken out from your quota, and has the same feature as the scratch file system, and will be cleaned up in the end of the session or job. And for information, there are also a set of in-memory location. However, just for advanced use case, that don't, let's say, otherwise it's better to stick to the using TMP-DIR or scratch DIR otherwise. And finally, there is the latest addition that is the local SSD, which is basically very similar to the TMP-DIR in terms of feature, because there are 3 GB of default expandable by request to up to 100, and is very specific to the interactive sessions that are created via the ECE Interactive tool that we will cover in this presentation, or via the Jupyter Hub. So the difference with the TMP-DIR here is that at the end of the session, the content is not deleted, but is archived. And then when you open a new interactive session via one of these tools, you have the possibility to restore via a dedicated command the content of the previous sessions. So finally, at any point in time, if you are on the facility, on the system, you want to review your current usage and also the limits if you don't want to check the documentation, you can run the quota command that will tell you how much you are using and also which is the limit. Also, you can refer when you are on the system to every of these locations with dedicated environment variables like $home, $SPC-perm, and so on. And you can also use them in your scripts or your application. It's also a good practice in case in future the absolute path that are mapped to this variable will change. In terms of file transfer, to move data in and out from the HPC to your local machines, once you have a teleport configured, you can use any tool that runs over SSH, like the common rsync, SCP, or SFTP. In addition to those possibilities, you might use some tools from the ECS service, that there will be also a session for that during this course. And one of the possibilities to do SFTP to the boaccess.ecmwf.int, which is the ECS gateway at ECMWF, or also using ECTrans to push data from the SPC to a remote site in an attended way also. For advanced use case also, there are other tools like the BBCP that are able to parallelize the transfer between two hosts. In terms of software stack, if you are a user already of or you have been of the ECMWF facility, or you have been using some other SPC elsewhere, it's likely that you have already used the module command. So module basically allows us to manage a lot of pre-installed software and packages, as well also their versioning on the system, and also the interdependencies between them. There are more than 400 modules available on the system nowadays, and you can use this module with a very simple syntax like a module load to load a package or unload, list to check the preloaded modules, a while to check which are the packages available, also their version. Spider is similar, but showing also, let's say, the package that the module that you cannot load directly. Module show will tell you which environment variable will be set, and also other settings that are applied when you load the module, and help will give you a description of the module. And finally, reset to restore your default, let's say, environment. So now we can have a brief demonstration of how to use that module command. With module while, you can check whatever modules are present on the platform. We count here compilers, ECMWF packages, and several third-party tools as well. And if you want to check the explicit version of a package, in this case we demonstrate via ECFlow, you just do module while ECFlow, you can see all the versions that are available. The D tag indicates the default one if you don't specify a specific version, and you can load also the module specifying the full version or some other tag like new. Now, if for instance you want to load a module, you can do module load ECFlow, and in that case, it will load the default version. Then you can see with module list that you have loaded the correct modules. Then if you want to update to use the new version of the module, you can just either use the specifying the version or just use the tag new, and it will automatically swap from one version to another. Then you can use also the shortcut ML for module list to see the module. And now if you want to load other modules like module load git, ML git, you can do that as well. Now, if you want to revert to the default, as I said, the module reset to come back to the previous original settings. In terms of ECMWF software, you might find that some software are available within the ECMWF-Toolbox module bundle, which is a bundle of different ECMWF packages that includes, for instance, EC codes, which is the library for encoding and decoding grid and buffer files, Magic for visualization, MedView for post-processing analysis, and so on. So if you do module load ECMWF Toolbox, you have all of them available. And with module help ECMWF Toolbox, you can check the specific version of each package for that specific version of ECMWF Toolbox. So this doesn't include all the ECMWF packages, and you might find that some of them, like the previously demonstrated ECFlow, has their own standalone module. There is also a wide support for Python user. We offer a centralized Python 3 installation, so no support for Python 2 on the system. And this central installation comes with more than 400 Python packages together with that. So you can do module help to review all the packages that are pre-installed. That includes either ECMWF software or common Python tools for data processing, visualization, data science, or even machine learning, and also the bindings for other ECMWF software as well. If that doesn't, let's say, is not sufficient for your needs, you have also the possibility to create your own Python environments via different ways. So the first one will be to create, for instance, a Python virtual environment via Python 3 -nvm. And if you use the --system site packages, you can also inherit all the pre-installed packages from the centralized installation. You can further customize from there. There are also, if you're a Conda user, you can also create your own Conda environments. And the recommended way to do that nowadays is via using the module Tiki. So these Tiki modules allows you to containerize your Conda stack within, let's say, a container. And that is, let's say, offer better performances compared to Conda environment, also a better use of the file system. So to do that, as is shown here, you just need to do modulo Tiki to run a command to create your container by passing an environment YAML file, including, let's say, your environment settings and the library that you want. And finally, you can activate this environment if you're ready to use it. If that, for any reason, doesn't fit your needs, you still have anyway the possibility to use Conda to create your own environments. In both cases, if you either load the module from Ticket or the Conda one, all the other system modules will be unloaded by design, because that allows you to avoid any conflicts with the binaries and tools that comes with the system modules. Also, will be just allowing a public Conda channels to set up your environments, like Conda Forge. So in any case, we recommend to start and create your environments either in your home for small ones, or using HPC Perm for bigger environments. Not avoid to use the Perm. We offer also container support, so you have the possibility to run containers on the HPC system, and that happens by using the modules Uptainer. That was previously known as Singularity. So this Uptainer allows you as a user to run containers on the system in a rootless way, so not requiring root or admin privileges like it is required for Docker, that is indeed not supported on the system. However, you can still use Docker container images and any other OCI-based image. You can build your container image elsewhere, or have them stored in a container registry or on Docker Hub, for instance, and you can run and use them on the HPC. Finally, I show you how to create and use interactive session. So when you access the system via SSH, you end up on a login node where you are constrained in terms of resources, so CPU and RAM that you can use in that session. And that, of course, because these login nodes are shared with multiple users. So it might happen that also that you might require to run some tool, some application interactively, so not via batch jobs, and still requiring a certain amount of resources. So to support that use case, we offer this possibility to start this interactive session and to customize a certain number of resources that will be reserved to those sessions via the ECMWF tool, which is basically a script that is made pre-available on the HPC or also on VDI, but you can even download on your local machine and start it from there. So here you can see the help. There are some options that allows you to customize the number of CPU, memory, and also the duration of this session, since this interactive session will be time limited. So we can have a short demonstration here on how it works. So interactive -H will show you the help that we mentioned. There are also some defaults that if you don't specify anything will be used, like 2 CPU, 8 gigs memory, or 12 hours for your session. So if you don't specify anything and run ECMWF, the session will be created on the system. And it might happen on one of the complexes. So in this case, it was on AA. And you can see also the compute node where the session has been created. And since I didn't specify anything, you can see there are default settings applied. Now, if you open another terminal, you can also reattach to the same running session. So you can then reconnect to the same session just by running ECMWF again. And then if you log out from one of them, so just exit or log out, you can see that all the other open connection will remain unaffected and will still be running as far as, let's say, the session is not expired. However, you can also decide to kill your session, and that you can do that by running ECMWF -K. it will ask you confirmation, and in that case, any other leaving session that you have on the system will be terminated. For ECS user, you can also specify the platform, which is by default the HPC, by just passing the option -P ECS. And also you can review, let's say, if you have any session running via EC Interactive -Q option. So with that, I concluded. So I'm open for any question before passing to the practicals.